With regard to the quiz, you should allow yourself about 10 minutes in total to complete all questions. Unless told otherwise, you should assume that vol is 30% and you should use the same yield curve as before. Each question is a multiple choice question with 4 possible answers. When you have identified the correct answer, click on Submit. You will be told immediately if your answer is correct. When you wish to proceed to the next question, click Done. Answers and the discussion are provided after each question. Question 1. Price a 5-year cap on 6-month LIBOR whose strike is 3% in years 1 and 2, 4% in year 3, and 3% again in years 4 and 5. For question 1, we open the worksheet labeled 3% cap. We need to add first the premium for the caplets in cells K6 to K9, which gives us $222,369, a number you can see at the bottom of the screen. We now change the strike to 4% and add cells K10 and K11. This gives us $270,903. Finally, we change the strike back to 3% and add cells K12 to K15, which gives us $2,282,419. The total of these 3 amounts comes to $2,775,691, so the answer is C. Question 2. Price a 3-year digital caplet whose strike is 3.5% and whose payoff is $20,000. In question 2, we open the worksheet labeled Cap Spread and set the strike for the first caplet at 3.5%. Cell K15 reveals a premium of $1,802 in return for a payoff of $5,000. But the payoff specified in the question needs to be $20,000, which means we need to purchase 4 times this amount of options. Thus, the total premium comes to 4 times the number in cell K15, which is $7,208, and therefore the answer is D. Question 3. An investor wants to receive 4 times his upfront premium if 6-month LIBOR in 2 years' time resets within a certain range. The upper boundary of the range is 4%. What should be the lower boundary? For question 3, we return to the worksheet labeled 3% to 4% range. We must first remember that the question specifies that the investor's view relates to the LIBOR reset in 2 years' time, so that cell W18 does not contain the formula we need. Let's program a new cell, say W11, with the formula equals K11 minus K25, since those are the cells containing the prices of the caplets expiring in 2 years' time. We now goal seek for the value in cell C3 that would make the value in our new cell W11 come to 1,250, which is 1/4 of the $5,000 payoff the investor wishes to receive if within the range. Tools, goal seek, set cell W11 equal to value 1250 by changing cell C3, hit OK, and the answer turns out to be 2.88%, which is answer D. Question 4. An investor has bought 2 digital caplets with a strike of 4%. One expires in 1 year's time, while the other expires in 4 years' time. Vol now rises from 30% to 50%. From a mark-to-market perspective, would you expect A gain on both caplets, B, a gain on the first caplet and a loss on the second, C, a loss on the first caplet and a gain on the second, or D, a loss on both caplets? For question 4, we return to the worksheet labeled Cap Spread and set the strike at 4%. The caplet expiring in 1 year currently costs $206. When we increase vol to 50%, the premium increases to $563. Thus, the investor would have a gain on this caplet. The caplet expiring in 4 years' time, when vol is at 30%, costs $1,667, as shown in cell K17. When we increase vol to 50%, the premium diminishes to $1,347. Therefore, the first cap has risen in value, while the second cap has fallen in value, and the correct answer is B as in boy. This effect was explained previously on the basis that the first caplet is out of the money, while the second caplet is in the money.